This chapter will involve preparation of a multi-ribs Teriva ceiling. But not only this, because in order to prepare this construction, we also must set the ribs on the internal and external walls. Reinforcement of the ribs will be connected, as you can see, with the substring reinforcement, which, as you know, are connected with supporting columns, which in turn are supported on massive concrete footings. The ribs is a reinforced concrete structure in the form of monolithic beams surrounding the entire building, which is designed to strengthen the load-bearing walls and provide support for the joints and the entire ceiling. Note that the beams are inserted inside the reinforcement and slightly raised so that they are accurately formed by concrete. In our case, our rib will be about 28 cm high and will be reinforced with 4 12 mm diameter rivet bars. This is a very typical in single-family housing construction. To complete rib, we have to do some formwork again. Since the execution of the formwork is relatively time-consuming and laborious, it is good to choose a ready-made solutions consisting in the set pre-made formwork system which use a keramzit shapes. We can see two types of formworks. Those which are presented now in L-shaped cross-section we will put on the external walls. Shallow gutter-shaped shuttering we will put on the interior walls in places where balcony slabs will arise, and in our specific case the walls of the outer corners facing the interior of the building. Formwork should be put with masonry cement mortar class B10, however, due to the fact that I was able to get the ideal plane of the upper surface of the walls, decided to use polyurethane mortar, and as you can see the effect is very satisfactory. It is another perk that obtained with the execution of the wall in the polyurethane system. I was able to save quite a bit time and money associated with the preparation of mortar, and I gained what I like the most, that is simplicity combined with the precision and clarity. That are the basic ideas of the creation of this course. Now you see the place where the ceiling Teriva will go into reinforced concrete slab supported by external lintels. I will tell about this on the next chapter. Here rises another substring. As you can see, it will connect with the reinforcement of the rib. Note the lintels here. The height at which they are is established in the project, but the size of the windows should be discussed with the investor, because they are elements that can be freely changed without major impact on the strength of the building. Next, on the edges of shaped, we will set concrete beam like the one you can watch. Inside them are reinforcing bars associated with the characteristic external reinforcement. Beams set in the axial spacing of 60 cm, as you can see in the film. Space between the beams we will fill using the hollow bricks, which are made in this case of slag concrete. It is the most popular and most affordable option. Hollow bricks made with slag concrete you will find 12 cellular at the best. There are also 6 cellular available, which although meet building standards, however, are less strong. Marginal blocks must be inserted at the time of laying the beams, just as is done in the movie, because if don't, the spacing between the beams will not be parallel, and you will not be able to push further the hollow blocks between the beams, which will result in the need to dismantle part of the ceiling. It looks like a child's simple system, and indeed it is so, apart from the fact that it is one of the more responsible tasks, and if you miss the basic principles of construction, you can cause a catastrophe that could put you and your employees to serious physical injury and cause considerable financial losses. Please note that from its bottom side, these blocks have locks allowing the suspension between the beams. The first beam must be placed directly near to the rib. On the other side, if you fail to hit the distance, you can arrange, for example, 2 beams or make a small shuttering. After preparation of the beams, that remains is to fill the empty space with blocks. This process runs very smoothly and quickly. About every 2 meters we ought to do so-called distribution rip, which is a 12 centimeters reinforced concrete beam arranged perpendicular to the joints, which acts as a stiffening. For its performance as the formwork, we will use flat shapes such as you can see in the film. We will put inside of this additional reinforcement consisting of 2 rebars. Then efficiently and quickly put another 8 rows of blocks. As you can see, the execution of this construction is like laying the large Lego blocks. If you accurately prepare everything from the beginning, all the work goes smoothly. We are set the blocks from the scaffolding which is inside of the building. Remember that unless you strengthen the structure using the pins, you can't walk on it. Most convenient way to underpin the ceiling is carry out it simultaneously with the laying of the blocks. I will tell how to do this for a while. After 8 hollow blocks we have a next distribution rip. We put here one-sided closed blocks, that is exactly as you see. In place of the distribution rip is formed a gutter. The reinforcement will be linked with the reinforcement of the joints. In this way reinforced concrete beams create a grate, which will form a monolithic structure combined with a wreath, columns, footings, and as you will see in the next chapter, also with lintels and external columns and reinforced concrete slabs. At the end of the structure we also place the closed blocks. If between the crown and the last blocks is free space, the easiest way to fill is to perform the wooden formwork and fill the gap with the concrete. Now take a look at exactly how the beams is placed between the wreaths. As you can see, we are moving in the desired direction successively. Place next 2-3 beams, fill it with the blocks, underpin on the bottom and put the next one. Ceiling units made of slag concrete are a bit brittle, so if there is a need to use a hammer, use a rubber one such as you can see in the movie. And again, time to distribution rip. What is also important is to submit a project of the ceiling in the building warehouse. The seller will be able to accurately calculate the required beams, their length and the amount of closed blocks that compose, as you can see, on the both sides of the distribution ribs and edges. Here the contractor doesn't put the spacers on the edge of the structure in the last 2 rows, and note that the last blocks are barely get in. If the ceiling was longer, it will be necessary to dismantle the last row, so as I mentioned before, always do so you don't have to correct, disassembly, modify, and certainly don't leave anything for later. Here you can see the underpin process. To do it properly, we will use the long boards, which we set perpendicular to the ceiling beams, then beneath of every one of them put a wooden stamp. It looks more or less like you can see in the film. Such boards we will place at a spacing 1.5 meter, while the stamps of course stand every 60 centimeters, exactly as stacked beams are placed. The whole structure must be firmly widgeted. Widgets after setting must be attached to each other or to the post so they don't have any opportunity to expand. Remember that the design should be done meniscus, so it's necessary to create a gentle curve facing upwards, ideally a difference of about 3 centimeters. Stamps upside screw to the boards, it stabilizes the entire structure and makes the work easier. After setting the supports, we move further by doing exactly the same steps. Teriva sealing is not the fastest or the best solution, however has a lot of advantages. First of all, the technology is very flexible. It can be installed in many variants. We can select the direction of the beams. It is easy and safe to base on it the substring formworks and perform breakthrough for the chimney. It is a very quick way to prepare the design and what is very important, especially for the layman, extremely easy. And this is how we put the beam between the rear and one of the substring. Note that the upper edge of the shuttering board of the substring is placed at the same level as the rear formwork. The beam is slightly inserted into the reinforcement of the substring and rear. Let's look again on the substrings made earlier. To the sides of the formwork, we screw timbers that are helpful when laying the ceiling beams. After laying the floor directly beneath the timbers, we will set the wooden pillars. Now you see one of substring which will get totally hidden inside of the ceiling. It is provided at this point because here will be resting one of the corners of the main truss. Directly on it we'll put short reinforced concrete wall, what will be in the next section. From the bottom of the substring we'll do shuttering using OSB boards that simply affix to the gap and underpin it. Here weird will be passed in the lintel in the shape of an arc, which will be supported by the outside pillars. Between such lintels will be reinforced concrete slab. This is what we will talking about in the next chapter of this section. The hole that every now and then is screwed through the film is of course a place in which will be a staircase. Now you see the place where the ceiling is past the chimney. As you can see from both sides we put it at double beams while the middle one is shortened. At this point add reinforcement that will support on these double beams. In this way we will build the so-called exchanges, which will be responsible for the maintenance of the central short beam. I think at this point all become clear for you. You met the idea and method of construction of the Teriva ceiling and weirds. In the next chapter you will discover that it is difficult to draw formwork in the shape of an arc, reinforced concrete slab and balconies. It will be equally interesting stuff with a lot of practical knowledge that will be helpful to you at the building site. Welcome and thank you for your attention.